ladies, we are going to work through the in-class review that would have been from today in class as part of our mostly chapter 8 with 1 or 2 problems from chapter 7 to help us review for those. So know that from chapter 8, we need to be able to graph rational functions, including asymptotes and domain and range. Again, domain and range would be on simple problems. We need to be able to add, subtract, multiply, and divide rational expressions and simplify them. We need to be able to solve rational equations, including looking for extraneous solutions. Remember, those exist when you end up with 0 in your denominator. So we cannot have 0 in the denominator. And then from chapter 7, we only got through sections 1 and 2. So from 1 and 2, we need to be able to graph exponential growth and decay, as well as use exponential growth and decay models. Now know that that will include both regular exponential growth and decay, y equals a times 1 plus or minus r to the t, as well as compound interest. And we do want to know that formula, a equals p times 1 plus r over n to the nt, where n is the number of times it's compounded per year. So example 1 comes from section 8.2, and we are graphing the rational function, identifying asymptotes, giving domain and range, and then describe how this graph is transformed. So we graph our rational functions mostly by plotting points, remember. So we want to consider what x's we need to plot. Well, in order to do that, we first talk about our asymptotes. So our vertical asymptote, remember, we find by setting our denominator equal to 0. So what number can we not have in the denominator? Oh, -3. So then from there, I would draw it in right away. And then not only do we have a vertical asymptote, we typically have horizontal asymptotes. And we find our horizontal asymptotes by considering if our graph has a k value. And this one does, because it's technically a transformation of our parent function, which sure enough it tells us in the instructions. But this k value is all we need for our horizontal asymptote. So for us, it's going to be y equals 4. And I actually apologize. Our vertical asymptote we get by setting our denominator equal to 0. We don't need the x cannot equal -3 until we start talking about domain. So while we're at it, we can actually do that. Our domain is almost identical. We would just say x cannot be -3, right? The vertical asymptote is the equation of the line x equals 3, which tells us that our domain is x cannot equal 3. So be careful when you have the cannot equals versus can equals. And then our horizontal asymptote affects our range. So we say that our range is everything except for y equals 4. So y cannot equal 4. And then we can get that drawn in. And now we can kind of think about what points we want to plot. Well, if we consider our vertical asymptotes, we want to pick x coordinates to the left and to the right of that. Now, if you're savvy with picking out numbers that would be quote unquote nice numbers to plug in, like it would give you a nice number in your denominator, great, do it. If not, just go ahead and plug in numbers to the left and to the right, and don't worry about what sort of numbers it's going to spit out. So let's pick numbers to the left of that vertical asymptote. And so some x's we might want to consider, maybe, let's see if that's at -3. Just go -4 and -5. Why not? And then we can go to the right of that vertical asymptote as well. Maybe we go -2 and 0. So plugging in -4 first for x, then we will have -4 plus 3, that's -1. -1 divided by -1 is positive. 1 plus 4 would give us 5. -4 up to 5. And then we've got -5. So -5 plus 3 is -2. Well, -1 divided by -2 is 1/2. Plus 4, that's 4.5. And so already with just those pieces, we can see what that branch would look like. Remember, our rational functions approach our horizontal asymptote as we go to the left and right, and our vertical asymptote as we go closer to our vertical asymptote. Then we plug in -2, and we get a +1 in our denominator Negative 1 plus 4 gives us a positive 3. So we plot that point. And then lastly, we're going to go ahead and plug in 0. Negative 1/3 plus 4 would be 3 2/3. And again, we only have one distinct option for what our right-hand branch would look like. So there we have it. Now, in terms of how our graph is transformed, consider your A, H, and K values. Our A value is that negative 1. So since A equals negative 1, that tells us that our graph experiences a reflection. Since we have this H value of negative 3, remember it's always the opposite sign, that tells us we have a horizontal shift or translation. And since it is negative, it is to the left 3. And lastly, because of this K, we already talked how that affects our vertical asymptote, our horizontal asymptote, but it also tells us that since K is 4, we have a vertical shift up 4. And there we have it.